it just so happens that I was watching, browsing YouTube a little bit, and it suggested a link just the other day, and it was one of yours. And the title was, okay, I don't remember exactly the title, but it was basically, uh, "Don't do end-to-end testing."
Yeah.
And at first, I looked at that and I just thought, "Oh, Dave, you're killing me here. No, come on." And my feeling is every time I go to a new organization, talk with a new client or whatever, and say, "Hey, let's take a look at your QA, let's take a look at your testing," it's almost always abysmal. So anybody saying, "Don't do insert anything you want here, testing," and I'm like, "No, no, no, do as much as you can." But then, of course, I listen to it and I watch the whole thing. I'm like, "Okay, I can get on board with that."
Yeah. Well, I hope so. Yeah. So the idea is, I'm with you. I think that testing. I think that testing is not only important. I don't really understand what software development means in the absence of testing. I think that we should drive all software development from testing, automated testing. I'm a test-driven developer and a BDDer and all of those things. My point in that particular video where I was talking about end-to-end testing is the kind of manual testing that people tend to fall into when they don't want to do a very good job of testing, where they just kind of put everything together and play with it a bit. And I don't think that works. I want to take a much more thorough, much more engineering approach to evaluating changes in the systems that I'm involved in building. So I want to drive the development from testing. I want to create what I call executable specifications of the behavior of the system. And in order to be able to do that, you need points of measurement. So you need to be able to measure the software and its interactions. If you do end-to-end testing, there aren't any points where you can measure very effectively because you've got lots of other systems and lots of other pieces of code that are getting in your way. If I'm writing a piece of code that's downstream from some other system and that other system's really there in my test environment, then I can't simulate cases where that system's sending me garbage or where it isn't there or you know my ability to respond to it is flaky or any of those sorts of things. So if I want to test my software thoroughly, I need to think about the points at which I'm going to measure it, and that's what I meant by limiting the scope of end-to-end testing. I do instead an approach that is called acceptance testing, and these are automated acceptance tests. And the idea of those is to evaluate the system in lifelike circumstances, in production-like test environments, end to end, but only in the context of the software that I'm responsible for and my team's responsible for, not end to end in the sense of whole enterprise systems or whatever. And that's what I was complaining about.
Yep. I spent a number of years in telecom, so I worked on the radio network side and then in the messaging side, and then I worked in the billing side for a while. And in the billing side, we had this huge monolith, and it was a nightmare. And we decided we need to split it into microservices. So that was done. But every microservice was so tightly coupled with the one next to it that there's no way we can deploy this one or even test this one by itself. And I came up with, or I didn't come up with, I'm sure I had heard it from somewhere, but I said, we didn't change from microservice or from a monolith to microservice. We just distributed our monolith, made it much more complicated to test and impossible to maintain.
Yeah, it's a very common anti-pattern. And I'm a big fan of microservices, but microservices aren't the easy option. That they are in some ways more complex than the alternatives. And for exactly the reasons that you've mentioned, part of the definition of a microservice is that it's independently deployable. That means when we finish changing it, we should be comfortable to release it without having to test it with everything else. So we don't want to do end-to-end testing with all of the services together necessarily in order to be able to release this. I think that one of the things that I like about continuous delivery is there are lots of ways in which it gives us guidelines that steer us onto a more effective, stronger engineering stance path. in the direction of success. And one of the ways in which it does this is if we take the testing of our systems really seriously, and we really want to test them properly in the way that I've described in measuring the behavior in controlled circumstances, then that drives us in the direction of certain architectural directions and certain design choices to make our system more testable. And those are nearly wholly to the benefit of the software, not just in terms of the testing. They nearly always result in better architected systems. But one of the things that it very clearly does, taking that mindset to heart, is it defines the scope of evaluation.
Mm-hmm.
If I think about, what's the scope? What's a sensible scope for version control? What's the sensible scope for a deployment pipeline, the mechanism in continuous delivery that we use to evaluate a change ready for release? Then the sensible scope is a deployable unit of software. So whether that's an entire monolith, whether distributed or not, or whether it's an independent individual microservice, doesn't matter. The answer's the same, but the scale of the deployment pipeline, the scale of the repository changes. But what does it then take in order to be able to design an independently deployable microservice that you can release without caring what the other versions of the other pieces of software are? You need to get involved in things like contract tests so that you can just validate that the contract hasn't changed and all of those sorts of things, and maybe puts and adapters patterns in the design of the microservices, all of those sorts of techniques to just isolate a little bit your microservice one from another so that they don't care so much about what version changes in other parts of the system. And I think this is one of the many ways in which continuous delivery helps us with our design, not just with automating our testing and our deployment.
So we've got Dave. What is your take on applying CI/CD for ML applications? From your experience, what do you see practitioners struggle with when applying continuous delivery to ML systems?
So the first thing that I must say is that I'm not an ML expert. It's not something that's been at the core of my career. I've done a little bit of work with people and teams that are thinking about this. And I think it's interesting. One of my friends is an expert on machine learning systems, and she told me that the data said that something like 97% of ML projects never end up with anything in production. And one of the reasons for that is that the data scientists and people like that are organizing the information to train these systems very often don't have a software engineering background, and so don't fall back on they fall into the traps that we learned how to, some of us learned how to avoid a long time ago. So they don't use version control very often. Imagine for a moment if you're a conventional software developer not using version control these days. Catch up to the 1980s and it will help you. So the kinds of data that they're dealing with is big and complicated, which means that you should use version control. Version control is even more important to be able to manage it and to understand the changes that are happening in that data in order to be able to train these things. We had a bit of a go at trying to sketch out what a deployment pipeline would look for machine learning. And it's different, but it's similar. It's still a software development activity. Although the machine is involved, we're just kind of developing software, but differently with the machine learning algorithms generating an answer, a new algorithm that solves the problem. Weighting the neural net and all of those kinds of things based on the training data. So we can think of this as a development process, and we can organize it and get benefit from some of the practices. It does change how we think, but I think that there's still a lot of the ideas of continuous delivery that can be adapted and adopted in machine learning systems. The big difficulty with that, as I perceive it, at the moment is really the skills of the people that are involved in doing so. I don't mean to denigrate those people. They're highly skilled in other areas. All of those things are important. Really, whatever it is that we do, it's not specific to even software. That's how science works and engineering works. If we can optimize for fast feedback channels, conduct more controlled experiments, that's a better way of learning things. And so that's must help in machine learning systems too, I believe. I would look up Emily Gorsinski from ThoughtWorks as a great source on some of these ideas. And there are some good conference presentations from her that describe these kinds of ideas in much more detail and much better than I can do them justice.
Yeah. There was one nugget in there that I wrote down. I'm going to use it. If you're not using version control, catch up with the 1980s, and then we can help you.
Yeah.
But I think that's something that I've been guilty of in the past, not specifically with version control, but I go somewhere and I'm like in part of a new team or a new project, and I look around and I'm like, that's stupid. Why are you doing that? This is the best way to do it. Not realizing that there's 20 years of history behind how things needed to go that led to that decision.
Yes. Yeah. None of this is easy, and you'd hope that as an industry we're learning things and getting better. The problem is that when we don't manage to capitalize on that learning, we've learned many of the engineering things that we've learned in more conventional programming are less about programming really and more about just managing information at some kind of scale. So that seems like pretty generally useful stuff. Ideas like version control and short experiments, small changes, fast feedback, all of those kinds of things matter when we're in a difficult, complex environment.
Yeah. Hey, Dave and Andy, working on a legacy system, where would you start improving acceptance testing around new features, along business critical paths, or something different?
This is a very, very timely question, because I run a YouTube channel and I release videos at 7 p.m. on Wednesdays, and tonight's video is about that topic, as it happens. So my take is that I often talk about continuous delivery from the point of view of kind of an idealistic picture, from starting from scratch, and that's because that's the easiest way to talk about it. It's the easiest way to do it. But almost nobody starts from there. Nearly everybody starts with a legacy. So there's a lot of experience of what it takes to migrate systems into continuous delivery environments, and it's a radical change. So there's a lot of stuff involved. So you've got to proceed carefully in small steps. And in my video tonight, I recommend that people check it out. If you go to YouTube, look up continuous delivery, you'll find my channel. Mm-hmm. Then I would recommend that you take a look at that video. It talks about 4 different steps, 4 different activities that I think are pretty much essential that we're going through. I can't remember if all of them off the top of my head, perhaps, but there's refactoring, automated testing, deployment automation, and one more which I can't remember at the moment. But it's fundamentally, my favorite definition of what a legacy system is comes from Michael Feathers, which is a legacy system is a system without tests. Because if it had tests, it'd be easy to change. And the reason why we don't like it and we're worried about it is because it's hard to change. Flip that on its head. And so I have a book called Modern Software Engineering, which talks about what I think are the fundamentals of engineering principles. And one of the core sets of principles that I think are fundamental to all software engineering, whatever it is that we do, are the techniques of managing complexity. Ideas like modularity, coupling, cohesions, separation of concerns, those sorts of ideas. And if we want to work to maximize those things, the reason why a legacy system is difficult is because it's hard to change. The reason why these ideas of managing complexity are so important is by retaining our ability to change the code. So I would argue that the definition of quality for software is really grounded in our ability to change that software. There are, of course, lots of other things that we want, but if we can't change our software, we can't get those other things. So if we want our software to be secure, but security is an ongoing thing. The environment's changing all of the time. The threats are changing all of the time. We need to be able to change our systems to keep up. We want our system to be fast. And the way that you get to fast systems is by changing them all of the time and refining them until they're as efficient as possible. So all of those other things are built on this idea of being able to change our systems. So the problem that a legacy system is hard to change is a really deep one and a really important one. So the grounding principle of working with the legacy systems is start getting it into a position where you can change it, at least in the places where you need to do work.
Yeah. I've often heard legacy as kind of like shorthand for that's old stuff which I didn't invent, so it can't be very good.
Yes, and that's not true either, which is something
Absolutely
that I mentioned in the video. Legacy systems are often the systems that are making your business, the money.
Exactly. I like Corey Quinn jokes once in a while that what does that legacy thing do? About $3 billion per month in billing.
Yeah.
All right, we got another question here. It's a long one, but let's tease it out. A modern approach to software development uses small, autonomous, cross-functional teams taking the responsibility for an entire product with everything that includes. Example, front-end development, back-end development, security, operations, business intelligence, etc. Combined with T-shaped teams, each member is expected to take on every complexity that the team is responsible for. Any thoughts on how to strike a balance with an autonomous team, but decreasing the complexity and cognitive load that the team has to take on?
Yes, and I think that the way that question is couched, the asker probably already knows the answer, which I think I think one of the most important books that's been published in recent years is team topologies, talking about the way in which we structure teams in order to manage that cognitive load, to reduce the load in each team. I think you can think of this as just a pragmatic response to the reality of the system. As an information system, software development really doesn't work in large teams, highly coupled. There's some lovely data that says that teams of 5 people are nearly 4 times as efficient as teams of 20 people, just on raw productivity in terms of lines of code, and they produce higher quality code. So we must divide our organizations up into smaller pieces. And also, in order to, the state of DevOps, the DORA metrics that I've got a t-shirt about at the moment, says that one of the most highly correlated ideas with good scores on stability and throughput, the quality of our systems, and the efficiency with which we can produce software of that quality, is autonomy in the teams, their ability to make decisions and choices without coordinating or relying on people outside the team. So yeah, now we're in this conundrum of needing small teams that have all of the skills that are necessary. So working to reduce the cognitive load is the teams just need those skills represented, and they need it enough in a big organization, in a big development. They need enough skills to be able to solve kind of 80% of the problems, and they need enough skill to be able to know when it's outside of that 80% where they need to call on for extra help, and then they can draft in an expert during a particular sprint or iteration to help them on a particular tricky feature. And during that period, the expert can be helping to coach them. In team topologies terminology, that's called an enabling team. And that helps to reduce the cognitive load, but also helps them to grow their skills over time. Every now and again, when they need it, an expert comes in and they shows them something specific, but exactly in the context of their work. And then there are other kinds of teams called platform teams. And the idea of a platform team is to help what are called the stream-aligned teams, these small T-shaped people teams that are developing the real value of the software, the fundamental value of the software that users would recognize, but help them to do the job more efficiently. So a platform abstracts away parts of the problem to reduce the cognitive load in the stream-aligned teams. And I think that's a very good way of thinking about it and a good way of working. So there's a service to the stream-aligned teams, and their job is to take effort away in a general sense from the stream-aligned teams. And there's lots of good stuff in the team topologies book that goes much further. There's a fourth type of team, which is a complex subsystem team, which once again, they're dedicated at particularly complex areas. You were talking earlier about things like telecoms and messaging systems and those sorts of things. You could imagine those being slightly divorced from other parts of the system, and other teams just relying on those sorts of more technical parts of the system that specialists work on. So there's a variety of ways of carving this up. If you're not familiar with it, I definitely recommend to everybody read the Team Topologies book. It's an important book in our discipline, in my view. I've also got a couple of videos which talk a little bit about it. They talk about platform teams and how to design platforms, and the Team Topologies idea of the way in which these different teams interrelate. But I think that's the key to being able to manage this difference between the demands of being able to own responsibility for our work within one of these small teams and have all of the skills necessary to do so, but also not become overwhelmed with all of the things that we need to do.
Yeah. So I started my career in the United States Navy doing submarine electronic warfare and whatnot on fast attack nuclear powered submarines. And one of the final exams before I could get my qualification pin was I had to list like every single system and how they worked with each other. And there was a question like, you're a molecule of air, turn on this light. And you have to go through all the ventilation pipes and the diesel generator and everything. And anywhere I was standing on the submarine, if any situation, I knew what to do next.
Yeah.
So I knew the next 2 or 3 steps for every situation in every single space. But I promise you, you don't want me operating a nuclear power plant. So it was very much a key of balancing that. I understand how big picture this works. I understand what the normal flow was, and I understand when it gets outside of that, how to recognize and who to call next.
Yes. Yeah, absolutely. And I think that points to an important idea. Software development, clearly the kinds of systems that you were working on in the Navy, but also software development are highly complex systems. They're more complex than any one person can deal with. And so we need to abstract the problem in different ways. But you must have that kind of overview, that big picture. I consult for a living, and I often go into other people's organizations, and it's unusually, disturbingly common to meet people working on development teams that don't know what the software that they're working on really does, or the context in which their part is used. I don't understand how anybody can do a good job in that circumstance if you don't understand how it fits into the bigger picture. So at some level, you've got to have that bigger picture. You've got to understand the context in which your software is working, at least a couple of layers out. But as you said, I kind of like to have at least a kind of tourist map understanding of the overall goals and workings of the system, so that I can then understand where my stuff fits and when I'm in trouble and I'm getting beyond the boundaries of what I ought to be worrying about.
Yeah, exactly. The main host of our conference, Mark, and I often do consulting gigs together, and quite often we'll go in and we start asking all kinds of questions and visiting different teams, and then we come back and like, okay, so this is da-da-da. But how do you know that?
Yeah.
Have you talked with that guy over there who sits in the same building? And just kind of, it's sometimes shocking that we don't have this, or typically software companies don't have this holistic view, and it shouldn't take somebody from the outside coming in to help them find it.
Yeah, and that's another aspect for me of continuous delivery, which is not often talked about, but working so that the information flows through the organization in the right way. So I'm relatively, I'm not didactic, but I believe strongly that there are good ways and bad ways of doing the kind of automated testing that kind of drives the development. So using executable specifications and so on. If you get that right, and we specify what we want our system to do only in terms of outcomes rather than in the implementation detail, then it's almost it tells you exactly what it is that we need to test. It tells you what we're building stuff for without telling you how to build it. That's a very good thing, because now we can change our minds about what we need to do to achieve those outcomes, and those outcomes don't go out of date. And it communicates the kind of ideas that you're talking about throughout the whole organization in a consistent way, rather than each little separate silo having a different way of thinking about and describing the problem, which is not
My
going to end up with a
dashboard
good
looks
solution.
fine. I don't know what you're seeing, but mine is fine.
Exactly. Yeah.
All right. We've got another question here. When you have tiny development teams, less than 20, and many repos to maintain, like over 200, how can you efficiently template your infrastructures, code, and pipelines to improve consistency across the repositories and decrease pipeline drift?
There's an old joke of one person walks up to another person and said, "Can you tell me the way to the opera house?" And the other person says, "Yes, I can, but I wouldn't start from here." So the starting point is that I'd question the premise of I'd query the premise of the question, really. So why have you got a team of 20 people dealing with 200 repos? What are those? What is the separation that those repos are giving you for? Why is that tool being used in that way? What's the value that it introduced? Sounds to me like it's introducing complexity rather than adding value. The next thing is, so if you have got multiple repos and you want some consistency, then you can do something like continuous delivery as a service. This is usually in a bigger organization, not in a team of 20 people. But in a bigger organization, it's sometimes worth having a small number of people that are responsible for building out some of the infrastructure and providing it as a service to others that can then build their deployment pipelines on top of a stable, maintained template. And that's not a bad strategy in a big organization. Yeah. For a team of 20, though, I think it's too small probably to do that. And, I'd be looking at trying to figure out, how to manage this better. And I think that people won't like this answer, I'm sure. But one of the ways of managing this better is to put stuff into fewer repositories. You can still have the same service boundaries. If the point at which I'm wrong in asserting that is if each of these things is independently deployable, you can deploy them without testing them with the other pieces, then fine, that's okay. In which case, consistency of your deployment pipelines doesn't matter. But I would argue that that's the wrong choice, the wrong architectural choice there, because microservices are an organizational scalability tool. They don't add anything else. There is no other extra value to a microservices architecture beyond any other kind of service architecture that we get. So building a distributed monolith is an expensive way of doing things if you do that by dividing it up into separate repos. Now, if I make a change in one repo and I need to change in another service, I've got to go into that repo, run that thing. I don't know whether they work together. It's all complicated. If they were all in one repo and one deployment pipeline, I'd make the change, run the pipeline, and I'd know it worked. So it's an awful lot simpler to deal with the boundaries that are real, that make sense. What's the deployable unit here? And I would argue that's the starting point, and you should align your repository boundaries and your deployment pipeline boundaries with deployable units in your system. Otherwise, the repos are getting in your way rather than helping you.
Yeah, I think that 20 developers and 200 repositories, there might be a reason for that, but that kind of doesn't pass the smell test. There's something odd there going on that could probably be restructured to relook at how you're doing this overall, as you've been describing.
Yeah. So in a big team, if there were, I don't know, 200 teams and there were 200 repositories, then that's fine. I wouldn't care about standardization at that point, because each team's looking after its own repo, its own deployment pipeline, and so on. That's fine.
Yep. All right. Wondering about the DORA metrics, and especially the fifth metric, reliability, as an aggregate metric. It's still a bit vague while very interesting. Do you see it as a nudge on the trend to truly incorporate operations runtime activities into DevOps?
I hope. I am a strong supporter of the DORA metrics. I confess I'm a little skeptical of the new fifth metric. I think level to the others, and I've spoken to some of the people in DORA about this, but my view is that it's already covered. So reliability is, you can either say that it's covered by stability in terms of the defects that we introduce into production, or throughput. If your software is unreliable, you're not going to be able to releasing it very quickly. So I think it's covered by those things, and they seem to be deeper metrics at the sense that they are more fundamental. The reliability metric that they've introduced feels more like an emergent property of those other things. I can understand wanting to measure that, but if you're going to measure that, there's a whole raft of other things at the same kind of level that I think I'd be interested in measuring. And I don't think, I'm not quite sure it's there yet. I'm not quite sure it's right, and I'm not quite sure. So I'm a bit skeptical about its utility in the same way. If my software is not being reliable, then what does that mean? Well, it must change the scores on stability. I don't see another way in which that can, because if it's stable but unreliable, what possibly does that mean? It doesn't seem to make any sense. So it doesn't seem like an independent measure to me, and it seems more like something to, I don't know, appeal to certain parts of the community. The idea of needing to placate operations people by including them in DevOps, they're in the name. I mean, the idea of DevOps is that it's a better collaboration between development and operations, in the sense, not just the people, but the thinking. As a developer, I need to be thinking about the operational capabilities of my system. I need to be knowing and understanding the deployability of my system, how my system operates in production, how it's configured in production, in order to be able to practice the techniques of continuous delivery. I need those things. As an operations person, I need to be able to use the tools of development to solve problems of observability and so on in production, and use techniques like, and I'm a big fan of the site reliability engineering as a good way of structuring the interactions between dev and ops, but also non-technical people, so that we can agree the parameters, the ways in which we're going to measure success for a particular change, and how we're going to observe that success, and what our error, our capacity for dealing with errors is in error budgets and those sorts of things. So I think there's an awful lot of operations already in this thinking. I don't think that we need to be trying to sell it to people. If we do, then that should be with better descriptions of the ideas, because I think they are already fundamentally part. We're not dismissing operations, to my mind.
So I have one last question for all those people watching. What's the single most important thing that a tech company who does software should start doing to be successful going forward? One piece of advice.
Improve the speed and quality of feedback. So that's what I'd say. I think that drives nearly everything else. So if you can imagine for a moment, you can commit any change to that's intended for your production system, and you can get feedback within an hour of whether your software is releasable into production or not. Just imagine that that's true. Ignore the technical difficulties. How would that impact on your development approach and thinking?
Yeah. And I guess some companies would look at that and say, an hour? Why are you waiting so long?
Yes.
Not many, though.
So an hour is the outside. An hour is what I say is the limiting case. Strictly, what I say is that we'll give you a pass if you can determine the releasability of your system at least once. It qualifies as continuous delivery. If it takes you longer than a day, it's not continuous delivery.
Yeah.
That's my view. And the faster it is, the better it is.
Yep. All right. Thank you so much for doing this, Dave. It's been great to chat with you and to meet you. And I really, really appreciate all you do with the book and the YouTube channel and everything, getting these important topics out there. And I'm glad I had the chance to dive in a little bit more. So
great. It's been a pleasure. Thank you.
Hi, we're from Eficode, and we're delighted to organize the DevOps conference.
The interactive track at our conference has a unique opportunity for speakers and audience members to engage in dynamic conversations. It fostered a collaborative learning environment. Our tailored coaching services can also help you to overcome challenges in your software development life cycle. Let's have a chat.
Connect with us at eficode.com and let's push the boundaries of software development.